Here's a typical Windows event message, shown here in JSON format. As you can see, it contains much detail about the Windows event, in this case event ID 4624, which is a successful login. We can see the computer name, the time that the event was generated, and much more detail about the event. But there is also much data here that is irrelevant or duplicated. For instance, the message string here is duplicated in the message strings array here, and there's operational data such as the offset of the data and the offset of the user SID that is irrelevant for analysis. By default, working with Splunk, we would write all of this data into Splunk's data store and be paying for its storage. Using the StreamSets DataOps platform, we can optimize our use of Splunk. In this example architecture, we have StreamSets Data Collector Edge running on hardware such as servers, firewalls, and routers, forwarding their logs to StreamSets Data Collector. In turn, StreamSets Data Collector writes data into a message queue, such as Kafka or Amazon Kinesis, and a second data collector pipeline can write the data to Splunk and to Snowflake. We'll focus on this second pipeline because this is where the filtering occurs that ensures we make maximum usage of Splunk. Here's that same architecture as a StreamSets control hub topology. We have a number of pipelines here. These StreamSets Data Collector Edge pipelines on the left collect data from the various hardware devices. They forward that data via HTTP to this pipeline that simply forwards onto Kafka. We'll concentrate on the pipeline on the right here, which sends all data to Snowflake and then sends a filtered version to Splunk for maximum efficiency. Let's start this pipeline and take a closer look in Data Collector. Over in Data Collector, the pipeline's running and we can take a look at its configuration. Here we're simply reading the server logs from Kafka where they're being written in JSON format. And on this upper stream here, we serialize that message string array so that it's more easily consumed by Snowflake. So we're serializing that array into a JSON string and then send it to Snowflake. This is the Snowflake Enterprise connector that is part of StreamSets for Snowflake. And we can see that we've set up a connection to a Snowflake account and we're feeding in data into this particular data warehouse, database, and this table. Now you'll notice here that I've set the table to auto-create. I didn't have to create any schema in Snowflake before I started this pipeline. In fact, we can take a quick look at Snowflake over here and see that there is, in fact, no Windows logs table present yet. On this bottom stream, we get to filter the data. So here, in this stream selector, we're only keeping records from the Microsoft Windows Security auditing log and discarding any others. With those records, we can then remove the unwanted fields. So we remove listed fields and remove things like the message that's duplicated in those strings, the reserved field, and so on. Then we can easily set up the record format to match what Splunk is expecting in its HTTP event collector. So we move everything into the event node and then create time, host, and source nodes with the existing data. Before sending to Splunk, we ensure that only those fields that Splunk is expecting are present. And then finally, we use the Splunk destination to send data to the Splunk HTTP event collector. Now, I don't happen to have a bank of Windows machines handy, but I can simulate the event flow by pumping messages into Kafka. We've pumped in about 26,000 messages, and if we go back here and click in the background, we can see that the pipeline is ingesting them at a fairly fair clip. It's ingesting hundreds of messages per second just here on my laptop. Now, if we click around the pipeline, we can see that 23,860 records were ingested and over 47,000 were output. Let's see why that is. We ingest 23,860 and send all of them via this path through the JSON serializer to the Snowflake destination. So all 23,860 messages are written there. Now along this lower path, we're actually filtering out 66 irrelevant messages going to that output 2, being discarded. And then the remainder, we remove those fields and send them on to Splunk, 23,794. Now going to the different destinations, we can see that if we refresh here now, that Windows logs table has appeared, and we can in fact run a count query. So see that 23,860 records are there, and actually do things like select the first 10. So various event IDs are there, and even start to do some analysis, like maybe we want to look at the successful logins and see there's 3,275 of them, and we could drill into the detail and create different analyses there. At the same time, we can look at the data in Splunk, and we'll just refresh here and see that there are those 23,794 events. Again, we've got them all listed out here. And again, we could drill down and 4624 successful logins and start to do more analysis there. So very easily, we've gotten control of our Windows event data. We're archiving everything to Snowflake, and we're only sending the relevant records and the relevant fields to Splunk. Thanks for watching.